Hello, viewers. In this virtual class, say y is equal to x raised to power 3 over 2. Find the YDS from first principle. Here we're going to use our first principle to find the derivative of s raised to power 3 over 2. And we know from first principle, here, y here will become y plus delta y, and in place of x here we have x plus delta x all raised to power 3 over 2, and we move this y to the right hand side, so we have delta y is equals to open bracket x plus delta x raised to power 3 over 2 minus y. And we know that y is this, so we put y is equals to x raised to power 3 over 2, that delta y is equals to open bracket x plus delta x all raised to power 3 over 2 minus x raised to power 3 over 2. Okay, what is next now is how do we expand x plus delta x all raised to power 3 over 2. Now we will use the binomial expansion here. S combination arrow is equals A combination arrow. Here we have a raised to power n minus arrow times b raised to power arrow, and the arrow is here. Arrow is moving from 0, 1, till n, and we should know that our n here is 3 over 2. Okay, and our a here is x, and our b is delta x. So we apply this principle here and see how we will be able, to arrive at the derivative of this from first principle. Okay, now let's continue here. If n is equals to 3 over 2, then arrow is 0. Here, we want to expand this. Look at what we're expanding here. X plus delta x raised to power 3 over 2. Okay, here we have a x raised to power 3 over 2 minus 0, because we said that is a raised to power n minus arrow. When arrow is 0, everything here bracket delta x raised to power 0. Okay, so and what we have there is x raised to power 3 over 2. Here we also have a n combination 0 here. That means 3 over 2 combination 0 will also give us 3 over 2. So you can try that. Please know that n combination arrow simply means n factorial over n minus r factorial bracket r factorial. So if we do this, n combination 0 will also give us n combination 0 will give us n combination 0 will give us 1. So if we apply this now, we see 3 over 2 factorial, then 3 over 2 minus 0 or factorial bracket 0 factorial. Okay, so that what we have here is 3 over 2 factorial over 3 over 2 factorial, and 0 factorial is 1. So this will go. So here will give us 1. Okay, having done that, that is the first this thing here. So if we are expanding this, delta y, the first this here will be x raised to power 3 over 2. So let's do for the second expression here. So if r is equals to 1, so we have we have 3 over 2 combination 1. Here we have x raised to power 3 over 2 minus 1. Okay, open bracket, delta x raised to power 1. Okay, here let's now find the coefficient of this term here when r is equals to 1. So 3 over 2 combination 1 is mean 3 over 2 factorial all over 3 over 2 minus 1 close bracket factorial bracket 1 factorial. Okay, so let's quickly do this. Here this 3 over 2 minus 1 simply means this is 2, 3 minus 2, that will give us a half. So here the coefficient here will be half, and from here what we'll be doing here is this. This is, if we want to expand it, this is 3 over 2. If we want to expand 3 over 2 factorial, it becomes 3 over 2 bracket 3 over 2 minus 1. We continue like that because of the fact that this denominator here is 3 over 2 minus 1 factorial. We stop there so that this factorial will go off with this factorial. So here we have 3 over 2 minus 1 factorial. 1 factorial is 1, so this will go off with this. So the coefficient of when r is equals to 1 will become 3 over 2. Here we have x raised to power half. Here we have just delta x that we have seen from there. Then let's now still move further. Let's move further. When r is equals to 2, r is equals to 2, so that this will become s will become s raised to power 3 over 2 minus 2. Here we have a delta x all square. Okay, and we want to find the combination here, 3 over 2 combination 2. So if we continue to do that one, if we want to do this, this will become 3 over 2 bracket 3 over 2 minus 1 bracket 3 over 2 minus 2 factorial, and all over here the denominator will become 3 over 2 minus 2 factorial bracket 2 factorial, so that this will go off with this, and what will be left here will be 3 over 2 minus 3 over 2 times here. If we expand this fraction, if we do this fraction here, will become half, and will become half. So here the coefficient, the next coefficient will be plus 3 over 4 s raised to power, here s raised to power minus half, because this fraction 3 over 2 minus 2, here the LCM is 2, this is 3, this time this is 4, so it's going to be minus half. That is the power of x here will be minus half, so that delta x, this will become delta x all square. And you know, if the process will continue till we get to delta x, or we get to delta x also raised to power 3 over 2. But what we do here, we put a dot here, plus 1 2 3 plus delta x all raised to power 3 over 2 minus x raised to power 3 over 2. Okay, that is the process here. What we need to be able, you look at this x raised to power 3 over 2 with this minus s raised to power, they are gone, and we will be left our delta y will become 3 over 2 x raised to power half delta x plus 3 over 4 s raised to power minus half delta x all square plus dot 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 plus delta x all raised to power 3 over 2. Okay, and the process here is that we're going to divide both sides by delta x, divide both sides, divide through, not just both sides, divide through by delta x. This become delta y over delta x is equal to, if this happen to this will become 3 over 2 s raised to power half, because there's one delta x here, this one will be off, and here there's delta s square. What will be left with 3 over 4 s raised to power minus half delta x plus dot 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 plus we have a this one will become delta x raised to power 3 over 2 minus 1, because if you divide this one, you are applying the principle of indices, the law of indices, it become this. Then as limit, next is as limit delta x tend to 0, delta y, delta s will tend to become the y, the x, so that all this one that has delta will be affected and they will tend to become 0, so that our dy dx here will become 3 over 2 s raised to power 1 over 2. So this is the derivative. Normally if we use from first principle, this time this minus this is what we're still going to arrive. So from first principle we'll be able to to establish this. Okay, please, all you help me do, please help me subscribe and also share to other platform, other social of your social platform, and hit the notification button so that anytime this video comes up, you have access to it. Have a nice time. See you in my next virtual class.